All right, so let's try 9. For this, you can't factor it. So you'll need to use the quadratic formula to solve. So note that it's an upside down parabola. It's written in the wrong format. So whenever you get confused or you feel like you don't quite understand, slow down and understand that this is just a parabola written in the wrong order. You can tell when time is second. This is a plus 10, leads with no negative, so it's a plus. You can tell when time is 0, it's 10. And since they describe that he's standing at 10 meters above the water, it's safe to assume that the graph does one of two things. It either starts here when he's at 10, he has to do a little dive and then hits the water, which is most likely. The only other scenario is that he's already at the height and just kind of falls into the water. But most times people do a little hop off the dive and do that, which means he hits the water at the x-axis. What is height at the x-axis? 0. They're considering the water since he's standing 10 meters above the water. 0 meters above the water is at the water. So they want to know when the diver enters the water. So what time? So that means we have to set height to 0. Height 0. So since this is not factorable, so we set our height to 0. So we have to use our quadratic equation. And the quadratic equation says that a is minus 4.9. B is 2, and C is 10. Also note that there will be two results for this parabola because it faces down. One of the results will be over here, but that is negative time. Along the x-axis, that's negative. There's no such thing as negative time, so we're only concerned with the positive result. So now we just fill it in. Notice that it's negative b, so whatever b is, we have to make it negative. So we're talking about one version that's negative 2 plus the square root of b squared, which is 4, minus 4 times a c. A is negative 4.9, and c is 10. It's quite clear that this one will become positive because it's negative 4 times negative 4.9. 4.9 times 10 is 49. 49. And 4 times 49 is 98, 196. 4 plus that is 200. So we're talking about the square root of 200 divided by 2 times a. A is 2 times a is minus 9.8. So that's one version. Minus 2 plus that. And then there's minus 2 minus that. Root of 200 divided by negative 9.8. So we got to calculate both of them. One with a plus, one with a negative. And you also have to be aware that you have to do the numerator before all on its own before you divide by minus 9.9. So the first one we get minus 2 we'll do the first one plus the square root of 200 divided by minus 9.8. Clearly this is going to come out as negative, so we're going to ignore it because there's no such thing as negative time. So one of the times is that. And this one is minus 2. Oh, I hope I did minus 2 the first time. It doesn't. I might go back and check. Second one is minus 2 minus the square root of 200 equals divided by negative 9.8. And that one's our likely answer. So that means that times this, she hits the water at this time. We can verify it in Desmos, but really what this one's interested in is a instantaneous rate of change. So since we know that the height, the y value there is 0, we can either take let's take a time that's slightly more, 962 plus h. And we need to find our second value, or if you want, our f of a plus h. This, I add a 1 to the 4th decimal, so it's right there. That's the time for this. And to figure out the y, we have to plug it into the equation. So I'm going to take what answer I have here, right there, and I'm just going to add my h to it. 3 zeros and a 1. And I get the same answer that I had down there. I'm also going to keep in my memory. So I have to follow the formula. First I square it. Then I multiply it by negative 4.9. Then I have to add 2 times it. Then I have to add 10. And yes, it's slightly below the water is what that minus is. Now I follow my f of a plus h minus f of a, all divided by my h, which is this. Well, my f of a plus h is the thing I just found. Negative 0.00141426. My f of a was minus 0, so I get that. And then divided by this. Well, this is the same as moving the decimal 4 places. So again, let me just check what that came out to. Yeah, I missed the, I'll take the whole thing. Don't need that many zeros, just enough. And then when I divide it by 0.001, three zeros and a 1, I get this, negative 14.142. Since we're measured in meters above it, and we're talking about a rate of change, it's meters of seconds, and notice it's negative, which means we're talking about a downward facing parabola where they're hitting the water right here. So they jump up here, hit the water, and when they hit the water there, they're going, the instantaneous rate of change is 14.14 meters per second down, or just negative 14.14 meters per second squared, or per second. And if you were ever in doubt, you would take your calculator. Remember, it doesn't like t's. Plus 10, I think. Was it plus 2x? Let's just go back and check. Plus 2x plus 10, yep. And notice if I set my height to 0, or I can just look at the graph. Sure enough, I got the time correct. So I can take that value of x. I can set my f of that plus h minus my f of that, which should be 0, all divided by my h, and all I need to do is tell it what my h is. 0, 0, 1. And sure enough, I get the same answer. Yeah, 14.126, and this one is minus 4. Yeah, same answer, just more decimals. So there you go. It's confirmed.